Welcome to the IBM Predictive Maintenance and Quality Demo. My name is Ishan Sehgal. I'm the Program Director of PMQ Product Management in IBM Business Analytics Software Group. Let's start with the dashboard. Represented here is the zoom in of the main PMQ dashboard, where we show the overall summary level view of the assets that might be measured or monitored by PMQ. Here we show assets located in 4 different locations with the average health score shown and the number of resources or assets in each location. We can see in San Francisco that there is a single asset there, and that asset has a low health score. You can see down below that there is a single asset, drilling machine number 11, shown in red, and we might want to investigate that further. Before we go deeper into the Cognos reports and how these are generated, let me do a little bit of setup of what we're looking at and how that data is being captured. So here we have a representation of a generic field asset. It's a drilling machine. There's several different measurements that we're looking at. Here, an example of that is an RPM. Another example might be the extension length of the drilling. Another example is the angle of attack. Another might be the tip temperature, the temperature of the drilling tip itself. And also external data that's not connected to the machine itself. Here, an example of that is weather or ambient temperature. There could be other examples of external data like personnel information or HR data. All of this combined could play a factor in the health of an asset. Along with measurement data is alarm data and log data. Here we see a low hydraulic pressure alarm. Let's see what happens as this scenario progresses. The asset manager is busy trying to monitor a lot of data, whether it's measurement data, log data, sensor data of all types. There are some alarms coming in. In this case, this hydraulic alarm is something that comes in quite often, and they most often ignore it because if there really is an issue related to fluid, such as a fluid leak, it's a little bit easier to detect, and so they usually ignore the hydraulic pressure alarm. They know that they would get behind schedule if they had to look at each and investigate each one of these alarms. They don't have enough maintenance personnel to look at them anyway. Secondly, if those assets were brought down for maintenance, that would have downstream impacts. In the meantime, there is an actual failure. The whole asset is offline. The maintenance manager is saying that it's already they don't have a part in-house. It's going to take another 24 hours. And the ops manager is worried that he's already behind schedule. Meanwhile, the asset operator himself might be enjoying a cup of coffee. This asset manager is thinking there's got to be a better way. There's so much data coming in. There's occasional alarms, not knowing what to do with them, mostly ignore them until an actual failure occurs, and then they have to react. Where could predictive analytics play a role? Well, predictive analytics would be used to understand their data environment. They could see a failure analysis and provide a predictive model for that and find patterns. The software looks for correlations of all kinds, looking at various measurement data from multiple sources, and identifies patterns for that. Here in this analysis, we did find that the low hydraulic pressure contributes to failure when the ambient temperature is high. We also see that high temperature contributes to failure when a particular type of hydraulic fluid is being used. This hydraulic fluid also plays a factor in a asset failure when the seal is old. This is what we call a multivariate analysis, and a single human cannot look at all the data and do this analysis in their head. There are several variables that occasionally come together that might cause an actual failure, and that could be potentially used to predict a failure. Here's where IBM predictive maintenance and quality come in. That once you do that ad hoc analysis and understand what are the variables and how those might contribute to a failure, you take a look at implementing that in a operational environment. But as in any environment, it's not just relevant or important to have a model that predicts a failure. You also have to have an actionable result. And here, in this example, the operators know that they could perform a simple flush procedure that would require minimal downtime. This flush procedure cools and softens the seal, and by knowing which of the fluids the machine is running and the age of the seal, the predictive model can tell us exactly when this flush procedure would be helpful. So let's go back and see how IBM PMQ would have helped in avoiding this costly failure. So we're measuring all this raw data coming in, the RPM, the extension length, the tip temperature, the fluid manufacturer type, the ambient temperature, humidity, hydraulic pressure, seal age. There could be many more, dozens or hundreds of other measurements coming in. And what we do, and this is very important because this applies across industries, across asset types, and across processes, is that we're pulling in all this data in real time, and we're providing we're aggregating it and profiling it into an asset profile. Here we do our KPI and calculations very quickly. Here we're doing some simple ones, the min, max, average, last, and we're storing only that data, that profile data, in our data store. Once we have that profile available for each asset in real time, we're able to take that profile data and run it through our predictive model. In this case, the model is calculating the health score. The higher the score, the better. And also in this case, at this time, the health of this machine is good. As time goes on, the profile is getting updated, the predictive model is being run in near real time, and the health scores are provided in near real time. Later in the day, the ambient temperature is getting hot, and the sun is out there. The other variables are changing. The profile has gotten updated on a regular basis, and so has the predictive score. Here, the score now has gone down to 50. So let's see what would happen. Well, our rules that we talked about earlier is that that simple flush routine should be performed when the score drops. Here, the rules are looked up inside of our tool, inside of PMQ, and the flush procedure is recommended. That recommendation could be automatically routed to a Maximo type environment so that a new work order is assigned to the appropriate technician for urgent action. So let's see how that would look back in our PMQ environment. In this demo, we'll start with a dashboard that we looked at earlier, and we'll have a data simulator that is actually simulating real-time data. This is an important point in that what PMQ has been designed to do so well is capture all kinds of data in real time, aggregate it, summarize it, and perform the analytics and provide a recommendation. In this case, we'll be running a simulator to run a baseline of humidity. Then we'll arbitrarily increase the humidity and see what happens. We'll also show temperature being measured, and we'll also increase the temperature and see how that impacts the health of the machine. We'll also see if that triggers a work order and show that in Maximo. The different administrative tasks that are part of this are the integration bus capability, the decision management rules, the predictive modeler using SPSS modeler, and master data management. Now let's look at the dashboard for the PMQ environment. With this dashboard shows different locations shown, Brentwood, Ravenswood, San Francisco, etc., and different number of resources in each location. The health score is shown at an aggregate level, as this dashboard is giving the aggregate view of all the assets in one location. You can see that a particular asset, drilling machine number 11, appears to be having a problem. We could drill down further and see that this serial number, SA121, has a recommended action that needs attention. We'll be looking at SA121 throughout this demo. If we go back into the dashboard, you could drill down by looking at various reports that are provided by PMQ. Here, this equipment report is one that we'll be looking at throughout this demo to understand what are the variables that are providing this particular action or contributing to the health score. We're going to now go into the demo, starting with the simulator, where we're simulating real-time humidity data. As I mentioned before, PMQ is a real-time environment, so we needed to not just provide batch or a file to score and demonstrate, but actually show how data coming in real time, perhaps PMQ attached to this asset, would monitor and report on its condition. Here again, humidity data is being produced, and we're going to see how for this asset, serial number SA121, how the data is represented, and if we change the data, how it might impact the health score. Here we have, again, the equipment report showing the humidity data. Here is the outlier report showing how the humidity data is within its limits. I went through that quickly, but we'll be coming back to this quite a bit in this demo. We're going to go now back to the simulator and increase the humidity and show how that increase in humidity impacts the health score or not at all. Here again, serial number 121 is being simulated data for, and again, that humidity data is now drifted upward, but not really impacting the health. The health score is still at 90%. Now let's go back to the simulator and simulate temperature data. Again, the temperature data is being captured in real time by PMQ, and it'll be represented in real-time reports. We'll be again looking at that equipment report and see how that temperature data is being represented for drilling machine number 11. You can see here this temperature data is well within the control limits and represented in the equipment report. We'll go to the outlier report and again see how the temperature data is within limits. We're going to now increase that temperature by increasing the mean arbitrarily and capture that data and see if this increased temperature, now hopefully we'll get something a little bit more interesting. Yeah, sure enough, that temperature has increased. You can see how it's drifted upward over time. And now let's see from an outlier perspective how that contributes to the health of the asset. Sure enough, the temperature has increased to be an outlier, and it has impacted the temperature, the health score. The health score now is at 50%. based on our business rules and our setup, we know that when the health score falls this far, we have the ability, optionally, to create a work order. So let's go see in the maximal environment what that work order might have looked like. So here we are in the maximal environment. We're going to look up a particular serial number. Everybody remembers SA121 again, and see if, in fact, in that set of recommended actions, or in the set of work orders, if a new work order was created. Sure enough, a perform flush work order was generated for this particular asset. It was for SA121, and the date was as we had run this on 5/29, the simulator at that timestamp. You can see how now PMQ has taken this data in real time, processed it inside of our data schema, and represented the results in various Cognos reports. We're able to see it at an aggregated level in the dashboard. We're able to drill down into the various components of the dashboard. We're able to see a single asset and what were the contributing factors for the low health score. And then we were able to see how, in the case of a low health score, how that generated a work order in Maximo. Let's go through some of the predictive maintenance and quality administrative tasks. Let's start with the integration bus and show how various message flows are required for data input and orchestration inside of the PMQ environment. Starting with this flow, we have master data, such as the site locations being pulled into the PMQ environment. Here's a flow where measurement types, such as temperature, are being loaded into the data schema. This next flow shows how events can be input via batch or real time. Here, batch data is collected and parsed for the into the appropriate profile for update. In this next message flow, we show how events are used to update the profile. Here, an event integration input is the output of a modeler score. The score, as we saw in the demo, is part of the profile as soon as it's taken. So the profile is updated using this message flow automatically. In this last two message flows, we show how modeler is called invoked when required, when the profile is updated and that all the data has arrived in the appropriate and collected in the appropriate order. It's only then presented to modeler for scoring. In certain situations, the modeler output needs to produce a work order. So this is the message flow for how modeler is used to produce that work order for, in this case, moving into a maximal environment. Here we have modeler itself shown. We have the model details shown here, where the fields are shown of temperature, seal age, pressure, humidity, etc., and the target or health score is being shown. The model itself we looked at earlier. It's a decision tree that uses multiple variables, humidity, fluid manufacturer, temperature, to represent the health score. It's only a combination of those variables that result in a lower health score, and you can look at that from an administrator can look at that inside of Modeler within the PMQ environment. Here we have how decision management combines the statistical output along with the institutional knowledge. That institutional knowledge are represented by either sometimes you inspect or maintain, perform maintenance, or you do other functions. Here, the recommended actions of flushing, replacing, seal, replace, or inspecting a drill arm based on certain rules are captured. Here, within Optimize, based on the statistical result along with the business rules that are input, only then will a certain action be recommended. This decision management environment is available for PMQ administrators. We mentioned earlier how master data can be manipulated or entered through our integration bus, but it can also be entered or edited through another tool within PMQ called Master Data Management. Here we've created inside of PMQ a standard simple template where business users have a safe and easy place to enter data, master data. In this case, we're adding a new machine number 9 into the environment. From that simple configuration, now a new machine is added, and they didn't need to go into the database, or they didn't need to go into a tool like the integration bus to perform this function. That concludes the administrative tasks for the demonstration. Thank you for your attention.